This is R.D. Sharma Solution Class 12, Chapter 19. We are taking exercise 19.29, Indefinite Integrals. In this indefinite integrals, how to solve this type of expression. So we have integration px plus q. Inside under root we have ax square plus bx plus c. Now these letters px plus q, p and q can be changed. You can take it as L or M or any symbol or letter. Now how to solve this? Now px plus q, which is outside, we need to represent it in the differentiation form of ax square plus bx plus c. So what I am suggesting is px plus q will be equal to d by dx, that is the differentiation of inside stuff, which is d by dx of ax square plus bx plus c, and then the differentiation will not be equal to that. That means if you differentiate this, most of the time it will not be equal to px plus q. So you need to have certain constant along with it in order to facilitate the equality. So we have lambda and mu. Again, the first thing, px plus q is a linear equation because the order is 1. X has power 1. Inside root we have quadratic equation. The power of x is 2, order is 2. So the linear equation is represented in the form of differentiation of the quadratic equation. Now what will be the next step? We need to find out lambda and mu. We assume that p, q, a, b, c are all known to us whenever this question will come. So if you have 2x square equals to ax square, what does it mean? It simply means a is equal to 2. Similarly, if I write 3x equals to say mu x, what does it mean? Mu is equal to 3. So let's differentiate this. It will be lambda. Ax square will be 2ax. This will be b and c will be 0 plus mu. And this equals to px plus q. This equation is very important because we are going to replace px plus q by this equation in the later part. So px plus q on the left hand side, let's equate it with these similar terms. So we have 2ax lambda plus b lambda plus mu. So we will make these similar term as equality. So px equals to 2ax into lambda. This is our first equation. We are just equating the similar terms. Q is a constant, so it will equate to b lambda plus mu. Now when we terminate this x or cancel this out, p will be equal to 2a lambda and q will be equal to b lambda plus mu. Please remember, only lambda and mu are unknown, others are known. So with these two equations, we are in a comfortable position to find out this lambda and mu. So these two will be computed. Now this px plus q, as I suggested earlier, in this integral will be replaced by equation number 1. So px plus q will be equal to, in place of px plus q, I am writing lambda into 2ax plus b plus mu, and then we have inside a root ax square plus bx plus c. Now let's multiply this. Integration will be lambda into 2ax plus b will be multiplied with the under root ax square plus bx plus c first. So lambda we can take outside. 2ax plus b into under root ax square plus bx plus c, and then we have mu, it can be taken outside. Inside this we have under root ax square plus bx plus c. Now let's call this first one as I1, other part as I2. Now in actual question we'll see how we are going to find out. See, 2ax plus b in the first I1 is simply the differentiation of ax square plus bx plus c. So if you have an integration of this type, where we have the f dash x and fx to the power n, that is the function to the power n and the differentiation along. So you can directly write the answer as fx to the power n plus 1 by n plus 1. So this simply will be ax square plus bx plus c to the power n is half here. So half plus 1 will be 3 by 2. And in the denominator it will be 3 by 2 plus 1. How about I2? We have under root ax square plus bx plus c. So we need to make it as a perfect square. So it will be in the form of x square plus a square under root. And this is the result which we are going to use. Under root x square plus a square dx will be equal to x by 2 under root x square plus a square by 2 log x plus under root x square plus a square plus constant of integration. Now let's see this question and try to solve it using the discussion we just had. X plus 1 under root x square minus x plus 1. So first thing is, we have to represent x plus 1 as, let us call it as px plus q. P is 1, q is 1. Under root ax square plus bx plus c, it is of the same form. A is 1, b is negative 1, c is a 1. X plus 1 will be equated as what? It will be lambda into differentiation of x square minus x plus 1. So x square minus x plus 1, and then we have a mu. Lambda and mu will be computed because all other things are known. So x plus 1 will be equal to lambda into 2x minus 1 plus mu. Now multiply this lambda inside, so it will be 2x lambda minus lambda plus mu. So let's write it as mu minus lambda. X plus 1 on the left. So x will be equated to 2x lambda. X will be equal to 2 lambda x. This is our first equation. X gets cancelled. Lambda is directly half here. In the second part, we have to equate the similar term. So the constant is mu minus lambda, and it will be equated to 1. Lambda is already computed, which is half. So 1 will be equal to mu minus half. Mu will be equal to 1 plus half, which is 3 by 2. Lambda and mu are computed now. Now this x plus 1 in this equation, which I am pointing or writing as 1, we will use this to replace x plus 1 because already a lambda and mu is computed. So let's call this as I. This integration will become half in place of lambda half, 2x minus 1 plus mu is what? 3 by 2. And this is just the replacement of x plus 1 in this terms. And the other part will remain same. So under root x square minus x plus 1 will remain like that with a dx here. So this integration, now let's multiply it inside and call it as I1 and I2. The first half into 2x minus 1 will be multiplied by under root x square minus x plus 1. So we have half integration of 2x minus 1 under root x square minus x plus 1. This is our first term. Then we have the second term, 3 by 2 multiplied by the under root term. So 3 by 2 I am taking outside, under root x square minus x plus 1 will be there. Now we have half and this term. Now you already know that this is fx, which is inside root, and power is half because under root x is simply x to the power half. So fx to the power half. If you take the differentiation of fx, which is f dash x, it will give you 2x minus 1. So x square minus x plus 1 differentiation will give you 2x minus 1. So integration of f dash x into fx to the power n, which you see here also, is simply directly you can write fx to the power n plus 1 divided by n plus 1. So in this case, what is n? N is half because root is actually the power half. So what is x? X square minus x plus 1. So I'm directly writing the formula now. Half is already outside. X square minus x plus 1 to the power 3 by 2 because half plus 1 is 3 by 2. Denominator you have n plus 1. What is n? Half. Half plus 1 is 3 by 2. Now 3 by 2 when it goes up it will be 2 by 3. So this 2 gets cancelled. 1 by 3 will come up in the front. So I1 is already done. I1 is simply x square minus x plus 1 to the power or raised to the power 3 by 2. And that is 1 by 3 also. A constant term. Now coming to I2. I2 is 3 by 2 under root x square minus x plus 1. So we need to integrate this. So x square minus x plus 1 we have to convert it into the perfect square. So whichever the middle term is there in the quadratic equation, you just take that term without the sign. Divide it by 2, square it, and then add it to the term, square it, add and subtract. So half square minus half square. So 3 by 2 integration. Now a square plus b square minus 2ab. So x minus half whole square. What is remaining? 1 minus half square. So 1 minus 1 by 4. So this will give you 3 by 4. So in order to make it as a perfect square, root 3 by 2 whole square will give you 3 by 4 only. So let's write this root 3 by 2 whole square. This is inside under root. Now do you see? This is under root x square plus a square formula. And the formula is already shown to you. It's x by 2 under root x square plus a square by 2 log x plus under root x square plus a square plus constant of integration. So let's write this. 3 by 2 will deal just now. So x minus half by 2 because it is x by 2, x is x minus half 1. Under root x square plus a square. This x square plus a square has come from where? It has come from x square minus x plus 1 only. We have added half square, subtracted half square by ourselves. Initially it was x square minus x plus 1 only. X square plus a square was that only. Plus a square by 2. What is a square? A square is already known to us. It is 3 by 4. 3 by 4 divided by 2 is 3 by 8. Multiplied by half, you will get 3 by 8. Then you take a log, and inside this you will get x plus under root x square minus x square plus a square. X is already x minus half in this case, and x square minus x plus 1 is like this. So then this x, just assume that I have written x minus half. I have just missed this negative half. So x minus half is what? 2x minus 1 divided by 2. This will give you 2x minus 1 by 2, and already 2 is there, means 3 by 2 has to be multiplied now. So we have 2x minus 1 by 2 into 3 by 2. So the first term of I2 is 3 by 8 2x minus 1, and this will remain as same, x square minus x plus 1. Now coming to the second term of I2, 3 by 8 multiplied by 3 by 2 will be what? 9 by 16. Inside this we have log, and keep it like this only. I'm writing it here, log. In place of x, I'm writing x minus half because it is actually x in this case. And this under root x square plus a square will be x square minus x plus 1 only. Now this is I2. Now just add I1 and I2, you will get the final result. So this I will be equal to I1 plus I2. And the final result, because we have computed I1 separately and I2 also separately. So 1 by 3 x square minus x square x plus 1 and to the power 3 by 2. This is our I1. Now coming to I2. 3 by 8, 2x minus 1 under root x square minus x plus 1. What is the third term? 9 by 16 log modulus of x minus half plus under root x square minus x plus 1 plus constant of integration. This is your final result. Integration of x plus 1 under root 2x square plus 3. Now we have a linear equation x plus 1. We have a quadratic equation 2x square plus 3. X term is not there. We can assume that 0 into x is there. This question will be done in a different way. Approach will be same. X plus 1 has to be represented in the form of 2x square plus 3 differentiation. That is d by dx of 2x square plus 3. But the differentiation will not be exactly equal to x plus 1. So we need to include a constant term lambda multiplied with the first term and then addition of mu. Mu can be 0 when we find it out in the later stage, but we have to have some constant in order to equate these two sides. X plus 1 will be equal to lambda. What is differentiation of 2x square plus 3? It's 4x and then mu. Now we need to equate the similar term. X with x, constant with constant. So x will be equal to lambda into 4x. And mu will be equal to 1. That is, lambda will be equal to 1 by 4 and mu will be equal to 1. Now let's put lambda and mu in this equation. So x plus 1 will become 1 by 4 into 4x. Now you will be tempted to cancel this 4 out, but this will not be a good idea. You will understand in a bit. In place of mu, I am putting 1 now. Now the integration becomes like this. In place of x plus 1, after all this processing, we will place x plus 1 as 1 by 4 into 4x plus 1. This is your x plus 1. And then under root 2x squared plus 3 will remain like this. Now we'll multiply this 1 by 4 into 4x with under root 2x squared plus 3. So I'm taking 1 by 4 out because it is a constant. I'm not taking 4 away from x. I'll keep that under root 2x square plus 3 there. Now multiply 1 with under root 2x square plus 3. So 2x square plus 3 direct differentiation will give you 4x. That is, if you have integration of fx, that is differentiation of fx, and then fx to the power n, when you integrate this, there is a direct result, or with all the background knowledge we have, we know that it will be equal to fx to the power n plus 1 to the power n plus 1. Now what do you see here? 4x is the differentiation of 2x square plus 3. So actually 4x is f dash x and 2x square plus 3 is fx and power is under root, which is n. What is under root? Under root is half only. So fx to the power half is under root 2x square plus 3. And f dash x is 4x, which is the differentiation of 2x square plus 3. So I'm writing the direct result fx to the power n plus 1, that is 2x square plus 3 to the power n plus 1, which is 1 plus half, which is 3 by 2. And denominator is 3 by 2. Now this 3 by 2 goes up, it will become 2 by 3. 2 gets cancelled out, we have 1 by 6. So the I1, which is the left part of I, is 1 by 6, 2x square plus 3 raised to the power 3 by 2. How about I2? So the I2 will be like this. 2x square plus 3 is also a quadratic equation. If you include a 0x, if you add a 0x, this will be equal to your quadratic equation only. But we are not able to solve it with the way we have learned. So we have to do a different tactic here. We have to get rid of this 2 from x square because x square cannot have any value, either negative or positive, in front of it. So I'm taking 2 outside. When you take outside anything, it's just the inside things will be divided by that thing. That is x square plus 3 by 2. Now under root into a, b is under root a into under root b. So you can separate this under root 2 from under root x square plus 3 by 2. Now this 3 by 2, we have to make it as a perfect square. So just write under root 3 by 2 and square it. Now you have a formula of integration of under root x square plus a square. X is x, a is root 3 by 2. Now I'm applying the formula x by 2 under root x square plus a square. Please refer to the right corner, upper right corner. You see the formula, I'm just applying that. X square plus a square will be simply 2x square plus 3 only because we have changed it. So the initial will always remain the same. How about a square by 2? A is root 3 by 2, a square is 3 by 2. So 3 by 2 whole square means root 3 by 2 whole square is 3 by 2 only and divided by 2. So 2 into 2 is 4, 3 by 4. Then we have a log. Then inside this modulus, we have x plus under root x square plus a square, which remains same, which is 2x square plus 3. So root 2 will be multiplied inside because root 2 was outside. Now root 2 divided by 2 is simply just multiply root 2 by root 2 to rationalize it. You'll get 2 by 2 root 2, that is 1 by root 2 only. So the constant term with the first term of I2 becomes 1 by root 2. I'm just writing it with some space because I'm going to include I1 here. So this under root 2x square plus 3 divided by 2 is the first term of I2. The second term is going to be 3 by 4 root 2, and then I'm writing log here, log modulus of, remember log will always have modulus inside, x plus under root 2x square plus 3 plus constant of integration. This is your I1. Now let's include this this is I2 actually. I1 let's include. So 1 by 6 2x square plus 3 raised to the power 3 by 2 was already done. So I1 plus I2, this whole is your final result from here to here. So this is your final answer. I hope you have a better idea now. Now let's see the formal way of solving this question. This is a reference for you. There is one more thing, one added thing you can do. You can do this up till here we are quite good. But from the last 3 lines which you see here, we can have a constant and we can combine this constant with the C, last C, and we have a different solution. But I think that up till where we have finished, it's okay. Next one is integration of 2x minus 5, and this under root 2 plus 3x minus x square. Now here will be some effort because 2 plus 3x minus x square, we have a negative x square here. So d by dx of 2 plus 3x minus x square, this has to be multiplied by lambda and mu in order to equate this with 2x minus 5. So we are trying to represent 2x minus 5 as the differentiation of the inside term of the root. What is the differentiation of 2 plus 3x minus x square? It will be simply 3 minus 2x. This is the differentiation plus mu. Lambda and mu, we have symbols. You can use any other symbol, but this is the normal traditional way we do it. Multiply the things inside and now equate. That is x with x, x square with x square, constant with constant. We don't have x square here. So 2x can be equated with negative 2 lambda x, which is the x term on the right hand side. This is the first equation. The second equation will be 3 lambda plus mu will be equal to negative 5. Now you see here 2 can be cancelled by 2x with x, so lambda becomes negative 1. So 3 lambda is actually negative 1, so it will be negative 3 plus mu equals to negative 5. So mu will become negative 2. We have the value of lambda and mu. Now drop it here. So when you place this lambda and mu, 2x minus 5 of the integral will become negative 1 into 3 minus 2x and minus 2. Mu is negative 2. So minus 2. Please keep this negative 1 here. So the integration will become like this. Minus 1 into 3 minus 2x. Now you'll see the power of negative 1, which is I haven't multiplied it inside. You know, it has to be kept separate. Under root 2 plus 3x minus x square remains the same because we have just changed or replaced 2x minus 5 in a different form so that we get a proper integration result. Now if you multiply this negative inside, negative 1, you will get 2x minus 3. But this will not be the differentiation of 2 plus 3x minus x square. Actually, it has to be 3 minus 2x only until you take negative 1 outside, or you just keep this negative 1 outside, you won't get the proper result. That is why whatever result you get, you have to keep it exactly like that. In the previous question, if you remember, 1 by 4 into 4x, normally you and me will do what? 4 and 4 cancel, x will be the result and x will put. No, you have to keep this 4x alive in order to use certain direct result of the integration. So 3 minus 2x will remain like this. Negative 1 I am taking outside as negative. Then you have 2 plus 3x minus x square because I have multiplied negative 1 into 3 minus 2x with under root term. And now the second term, which is negative 2, this will be multiplied with under root 2 plus 3x minus x square. Now this is your I1. Just assume that this is I1, this is I2. If you don't want, it's okay. You can do it directly. Just to separate these two terms as different and work it out, I'm taking the under root 2 plus 3x minus x square as fx to the power half. 2 plus 3x minus x square is fx, but 2 plus 3x minus x square differentiation is 3 minus 2x. So let's call it as f dash x. And you know that f dash x into fx under root or fx to the power n becomes fx to the power n plus 1 by n plus 1. What is fx? 2 plus 3x minus x square. This is our function. What is power? N plus 1. It's half plus 1, which is 3 by 2. So what you are going to get in the denominator? N plus 1. What is n plus 1? Half plus 1, which is 3 by 2. You have a negative outside. And this is equal to, because 3 by 2 will become 2 by 3 in the numerator. So negative 2 by 3. 2 plus 3x minus x square to the power 3 by 2. Now this is your I1, which is the left part of I. The first part we have solved. Now we have the second part, which is negative 2. I2 is what? Negative 2 integration, because negative 2 I am taking outside. The inside term will be 2 plus 3x minus x square inside a root. Now there will be a certain issue here, because we have a negative x square. We generally don't solve it in a way which we are accustomed to. That is, this quadratic equation is simply negative x square plus 3x plus 2. So we have to make it as positive in order to get some perfect square result. So just call it as, because 2 is already there, 2 minus of, now change the sign of negative x square and 3x and put it inside. That is, it's 2 minus x square minus plus 3x. So now you have this 2 minus x square minus 3x. If you open it, it will be negative x square plus 3x plus 2 only. Now why we have written this negative x square plus 3x plus 2 like this? 2, let it be like this. This x square minus 3x. Now you know that 3 can be divided by 2, square it, add it, subtract. So plus 3 by 2 whole square minus 3 by 2 whole square. We have to make it as a perfect square. So a square plus b square minus 2ab is x minus 3 by 2 whole square, which is a minus b whole square. And this 3 by 2 whole square will remain like that. Now 2 is already there, 2 minus, and when you open the bracket, the sign will get changed. So 2 minus x minus 3 by 2 whole square plus 3 by 2 whole square. So it's not 2 minus 3 by 2 whole square, because we have opened this square, these round brackets. So it will be 2 plus 9 by 4. 3 by 2 is, square is 9 by 4. So you have 8 plus 9 divided by 4, which is 17 by 4. So under root 17 by 2 whole square, which is the, when you square it, you will get 17 by 4 only. And minus x minus 3 by 2 whole square. Now a square minus x square formula can be applied here. You already have a on the right corner, if you see, we have under root a square minus x square formula already printed for you. A will be taken as under root 17 by 2. X will be x minus 3 by 2. Negative 2 will just deal later. Now applying the formula, x is x minus 3 by 2, so x minus 3 by 2 by 2. Under root a squared minus x square, which remains as 2 plus 3x minus x square only. Write it as 2 plus 3x minus x square. Then we have plus a square by 2. A is under root 17 by 2. A square will be 17 by 4 only. Divided by 2 will be 17 by 4 into 1 by 2, which is 17 by 8. And then after this, we have sine inverse x by a. So sine inverse, what is x? X minus 3 by 2 is x. What is a? Is under root 17 by 2. Now let's resolve this more. X minus 3 by 2 is 2x minus 3 by 2. 2 is already there, so it becomes 4. Under root 2 plus 3x minus x square plus 17 by 8 sine inverse. This x minus 3 by 2 will be 2x minus 3 by 2. Under root 17 by 2 is already there in the denominator. 2 gets cancelled. 2x minus 3 divided by under root 17 will come. Now negative 2 has to be multiplied inside. Let's multiply both terms with negative 2. So just assume that I am multiplying here with negative 2. Now I am going to add I1 along with this. Okay, we'll multiply my negative 2 and simultaneously we'll add I1 so that we get a I. What was I1? 2 by 3, 2 plus 3x minus x squared to the power 3 by 2. This was our I1. Now the first term, which is negative 2 multiplied by 4, it will be negative 2x minus 3 divided by 2. Under root 2 plus 3x minus x square remains unchanged. And here negative 2 will be multiplied by 17 by 8. So 2 4s are 8. It will be negative 17 by 4. So it's negative 17 by 4 and sine inverse 2x minus 3 divided by under root 17. So just keep it in the bracket. Always keep these things in bracket. This is I1. This is I2. We have added them together. And this is your final result. So this is your final result. The way I have done is projected here so that you can take a reference later on also. There are certain complication in this question and we have resolved it. Now this question will be, see, this is x square plus x plus 1 and all questions this have plus. So we can have a look here because we have already solved this question. So I think that anything with a negative inside like this question, we are going to take it and we are going to solve it. So we have done question like this. You have understood the methodology, the process. So under root x square minus a square will be used. That's why I showed this expression. Let us call this as I. and 4x plus 1, which is the linear equation which is outside of the root, and there is a quadratic equation inside the root. So 4x plus 1 has to be represented in the form of differentiation of x square minus x minus 2, and the differentiation will not be equal. That's why we need to include lambda and mu. These are certain symbols which we are using. You can use any symbol, and these are being employed just because 4x plus 1 will not be equal to directly differentiation of x square minus x minus 2. Now let's do the differentiation. D by dx, or differentiation of x square minus x minus 2, is 2x minus 1. Now let's multiply this inside and try to evaluate or equate the similar term. That is 4x plus 1 is equal to 2 lambda x plus mu minus lambda. So this 4x will be equal to 2 lambda x, and this mu minus lambda will be equal to 1. So here you get lambda equals to 2 from the first equation after equating the similar terms. When lambda is equal to 2, mu is going to be equal to what? It will be 3. Now this equation number 1, we have to replace lambda and mu by 2 and 3 respectively. When we do this, then we get the 4x plus 1 ready to be replaced in the original equation I. So I'm replacing or changing lambda as 2 and mu as 3, which we just computed, and this particular equation we just found can be, now this equation number 2 can be a part of original equation, and this will make our integration easier. So integration will be 2 into 2x minus 1 plus 3. It is essentially 4x plus 1 only. So 2 multiplied by 2x minus 1 plus 3. Then we have under root of x square minus x minus 2. So this is integration. This is dx. So let's multiply this inside. So I'm taking 2 outside. So 2x minus 1. And then we have under root x square minus x minus 2. Then we have 3. So multiply 3 by under root x square minus x minus 2. So we have got two separate terms which we actually intentionally try to divide, because now the integration will be in two parts, and that will make integration easier. That is I1 and I2. If we call this, I1 is direct. X square minus x minus 2, if we call it as f, x, 2x minus 1 will be equal to f dash x. So it's simply the differentiation of fx. So if you take the power of fx, which is half in this case, so the direct result of integration of f dash x, that is the differentiation of fx, and fx is raised to certain power n, then the integration will be directly fx to the power n plus 1 divided by n plus 1. And n is half here. Fx is x square minus x minus 2 in our case. I am only talking about I1, right? So 2 was already there. X square minus x minus 2 to the power 3 by 2 is there. And in the denominator it will be n plus 1, which is again 3 by 2. Now it goes up 2 by 3, so it will be 4 by 3 x square minus x minus 2 raised to the power 3 by 2. So the first part, which is the I1, we have already computed now. It will be 4 by 3 x square minus x minus 2 raised to the power 3 by 2. So the next step is to find out the I2, and we'll combine it with I1, and that will be our final result. So I2 is 3 I have taken outside, it's a constant. Under root x square minus x minus 2, which is a quadratic equation, can easily be converted into a perfect square. So x square minus x minus 2, you have the middle term in front of x is a constant, which is 1. We divide it by 2, square it, add it, subtract it. So I'm adding and subtracting this half square. So a square plus b square minus 2ab, which is x minus half whole square, is the first term. How about the second term? That is negative 2 minus 1 by 2 whole square. So it's just 2 plus 1 by 4. You can take negative outside. It will be simply 2 plus 1 by 4, which is 4 to the 8. 8 plus 1, 9. 9 by 4. 8 plus 1 by 4 is 9 by 4, which is essentially 3 by 2 whole square. We need a perfect square. That's why I have written 3 by 2 whole square in place of 9 by 4. And this negative was taken outside, if you remember. So it's not positive, it's negative. So x minus half whole square minus 3 by 2 whole square. Now under root x square minus a square formula is already being projected in front of you. You can use or employ this formula and use the direct result. So we are actually integrating under root x minus half whole square minus 3 by 2 whole square. In this case, x will be taken as x minus half, and a will be taken as 3 by 2. So we'll deal with this 3 later. X by 2. So x minus half divided by 2 under root of x square minus a square, which is essentially x square minus x minus 2 only. This is x square minus x minus 2. Then you have a negative. A square by 2. What is a? 3 by 2. So 3 by 2 whole square is 9 by 4. And then we have a 2 in the denominator as well. Log modulus of x is x minus half, plus under root, and same thing will come x square minus x minus 2. Now constant of integration will combine from I1 and I2 and call it as a common constant of integration. X minus half is simply 2x minus 1 divided by 2. You have a denominator already as 2 and 3 is multiplied. So 3 multiplied by 2x minus 1 by 2, and there is a 1 also in there. There is a 2 also in the denominator. So you'll get 3 by 4 2x minus 1, and then under root of x square minus x minus 2 is already there. What is the second term? Which is 3 into 3 by 2 whole square by 2. So I just left or forgot to write under root x square minus x minus 2. Just imagine that it is already there. Now coming to the second part, which is 27 by 8 log 2x minus 1 by 2. You can just keep it like x minus half only. It doesn't matter. Under root x square minus x minus 2 in modulus. Now I'm just adding I1 here. Please remember that I just missed under root x square minus x minus 2 in this term, 3 by 4 into 2x minus 1. So assume that it is multiplied by under root x square minus x minus 1. Now I am including 4 by 3 x square minus x minus 2 to the power 3 by 2, which is the first term, which is I1. So I1 plus I2. Now let me give you the exact solution, and whatever I have done is projected here, and this is the actual solution which you see here. So 3 by 4 2x minus 1 multiplied by x square minus x minus 2, which you need to note, and formula has to be under root x square minus a square, that you need to utilize and remember. So all the questions are almost similar. So we have x minus 2 outside, which is linear equation, under root x 2x square minus 6x plus 5, which is the quadratic equation. And this is how you can solve it, because we have done a question like this. 2 or 3 questions we have already completed like this. So this is for your reference only. Now since we have all plus plus here, so I don't think that you will have any problem. If you understood the first or second or third question, then there are questions coming up like this only. So I'll try to do that, but I'm just leaving it for you and trying to show you the reference. So 2x plus 3 under root x square plus 4x plus 3. Now just we have seen the question number 7. It also has all pluses, but you'll see a change here. So linear equation will be represented by the differentiation of the quadratic equation. 2x plus 3 has to be equal to d by dx of x square plus 4x plus 3, but it will not be equal because it will be only 2x plus 4 after differentiation. So you need to have a lambda in front of this d by dx. You need to add some mu, that is lambda and mu are the constant, in order to make the right hand side equal to the left hand side. So 2x plus 4 is the differentiation of x square plus 4x plus 3, which has a lambda in front and mu added. So let's multiply this inside so that we can equate it with the similar term on the left hand side. 2x lambda plus 4 lambda plus mu. You have 2x plus 3 on the left hand side, so you can equate 2x with the 2x lambda. So 2x along with 2x lambda, then we have 3 equals to 4 lambda plus mu. Now I just cancel this, 2 to cancel, lambda equals to 1 from the first equation after similar terms with x has been equated. Now constant term has been equated, which is 4 lambda plus mu equals to 3. Replacing lambda by 1, you get mu equals to negative 1. So in this equation number 1, just change lambda by 1, mu by negative 1, and then you get a 2x plus 3, which is quite comprehensible and can be put in the equation so that we get a proper, easier integration result. So 2x plus 3 I'm writing as a result, which we have done. 1 into 2x plus 4 negative 1 or minus 1. So this, don't remove this 1 in front of 2x plus 4. You'll see just now. So 2x plus 3 can be represented because integration is the whole expression. It's 1 into 2x plus 4 and minus 1. So this is just 2x plus 3. And this is followed by under root x square plus 4x plus 3. So x square plus 4x plus 3 has to be multiplied by these two terms. Don't try to make 2x plus 4 minus 1 as 2x plus 3 because it is essentially that. But we have done all the effort just to relieve get an idea to integrate it easily. So 2x plus 4 into under root x square plus 4x plus 3 is the first multiplication, then the negative is multiplied by under root x square plus 4x plus 3. Now you know that integration of f dash x, fx to the power n, is fx to the power n plus 1 divided by n plus 1. This is a direct result which we can employ in the first part. We call it as I1. Under root x is simply x to the power half. So we have n equals to half here. So 2x plus 4 is the direct differentiation of x square plus 4x plus 3. So I1 will be equal to x square plus 4x plus 3, and this raised to the power 3 by 2 because n plus 1 by 2 plus 1 is 3 by 2, and divided by n plus 1, which is again 3 by 2. It goes up and it will become 2 by 3. And then you have please remember it is negative also. Now this is I2. Let's call it as I2. We are integrating under root x square plus 4x plus 3. So under root x square plus 4x plus 3, what is the coefficient of x, which is 4, divided by 2, you'll get 2. Square it, add it, subtract it. So we are adding and subtracting 4 in this expression, or quadratic equation. So x square plus 4x plus 3 plus 4 minus 4. So x square plus 4x plus 4 is x plus 2 whole square. A square plus b square plus 2ab. So x plus 2 whole square is this one, and 3 minus 4 is negative 1. So you can call it as a negative half square. And this is integration. So we have x square minus a square. Now this is inside a root. So x will be taken as x plus 2. A will be taken as 1. I just missed the under root. Just imagine there is already a root, because we are actually essentially taking the integration of under root x square minus a square. So under root x square minus a square is x plus 2 by 2. Then under root x square minus a square is x square plus 4x plus 3 minus a square by 2, which is 1 only, 1 by 2. And then we have log modulus of x plus 2 plus under root x square minus a square, which is essentially x square plus 4x plus 3 only. Original thing. So under root x square plus 4x plus 3. Now there will be a constant of integration from I1. There will be a constant of integration from I2. Let's combine this, and final will be a constant C, capital C. Just call it as capital C. So I will be equal to I1 plus I2, which is x, which is first one is 2 by 3, x square plus 4x plus 3 to the power 3 by 2. And since it is negative, because we are dealing with negative here, so the sign is going to change. So minus x plus 2 divided by 2 under root of x square plus 4x plus 3. And then we have third term, minus minus will become plus, of course. So it will be plus log modulus of x plus 2 plus under root x square plus 4x plus 3. And this is a constant of integration. And there is one thing that I2 is actually under root x square plus 2 whole square plus 2. Please remember that, minus 2. So this is what the whole idea is. I hope you'll be able to do this. Okay. Now in this plus also, you have encountered under root x square minus a square. So the formula has to be learned by heart, because it will be used all through this exercise. This we'll discuss later. Thank you so much. Have a good one. Now in this question, 2x minus 5 is the linear equation and x square minus 4x plus 3 is the quadratic equation. Now most of the time we follow the rule and the method which I explained. But in this, you already know that 2x minus 5 can be easily written as the differentiation of x square minus 4x plus 3. In normal way, in normal terms, 2x minus 5 will be equated to lambda, which is the first constant, differentiation of x square minus 4x plus 3, which is the quadratic equation inside the under root, and plus a mu. Now this x square minus 4x plus 3 has a direct differentiation. The direct differentiation value is 2x minus 4. Now 2x minus 5 is already available to us. We can easily write 2x minus 5 in terms of 2x minus 4, because 2x minus 5 is equal to 2x minus 4 minus 1, and that will be equal to 2x minus 5. So this step, 2x minus 5 equals to lambda something or differentiation plus mu can be skipped. So this integration will become like this. 2x minus 4 minus 1 in place of 2x minus 5 we are writing, and inside this we have under root of the quadratic equation, which is x square minus 4x plus 3. There is a dx always. Now let's multiply this 2x minus 4 with under root x square minus 4x plus 3, which is our first term. I1 we can call it. So 2x minus 4 under root x square minus 4x plus 3 is our first integral. And then the second part, which we call as the second integral, is negative 1 multiplied by under root x square minus 4x plus 3. Now dx is always there. Please remember, I just skip it, but you already know integration, indefinite or definite, dx will always be there. Now this fx, x square minus 4x plus 3, the power is half because under root is half. Now 2x minus 4 is actually the differentiation of x square minus 4x plus 3. So the direct result of integration is fx to the power n plus 1 divided by n plus 1. That is x square minus 4x plus 3 raised to the power 3 by 2, because half plus 1 is 3 by 2. And in the denominator also 3 by 2 will come, because 1 plus half again. But when it goes up, it will form 2 by 3. Now first integral is done. This I1 is already completed. Now coming to I2, here also you don't need to follow the normal custom which we have agreed upon. Why? Because it's very clear that x square minus 4x, if you add a plus 4 and subtract a plus 4, it will be x minus 2 whole square. We can easily view it. Alright. What I'm saying is, it can be written as x minus 4x plus 4 minus 1. X square minus 4x plus 4 is x plus 2 whole square, or x minus 2 whole square to be precise. So just add a 4 and subtract a 4. That means you are actually adding 4 on writing 3 as 4 minus 1. Just write 3 as 4 minus 1. So those things which are self-evident, you don't need to go to all the steps which we have discussed. That is the whole idea of solving this kind of question. So we have x square minus 4x plus 4 as x minus 2 whole square. Only 1 will remain, so it can always be written as 1 square. So we have x minus 2 whole square minus 1 whole square, and this is under root, and this is your integral. Now you can always use this formula under root x square minus a square, which is a standard result. So I'm writing I2, which is the second part of our integral. Here a we are taking as 1 and x we are taking as x minus 2. So this I2 becomes x by 2, which is x minus 2 by 2. And whatever is inside under root x square minus a square is actually whatever we have got from x square minus 4x plus 3 only. We have changed it, and that those other things are the product of it. But the original will be x square minus 4x plus 3 only, which is essentially x square minus a square. And then we have minus a square by 2, a is 1, so 1 by 2 log modulus of x minus 2, which is x, plus under root x square minus 4x plus 3. And then you can add a constant of integration, but we'll combine these two, I1 and I2, and then we'll write a final constant of integration. So let me write everything clearly. First, I1 was 2 by 3 x square minus 4x plus 3 to the power 3 by 2, or raised to the power 3 by 2. And what is I2? Please remember there is a negative in front of it. I1 minus I2. So negative x minus 2 by 2 under root x square minus 4x plus 3. And since we have a negative, this negative will become plus. So you have a plus 1 by 2. I'm just writing this, in place of I2, I'm replacing the actual result. Half log modulus of x minus 2, then plus under root x square minus 4x plus 3, and close the modulus. Now you can add a constant of integration, which is the C1 and C2 of I1 and I2. Now this is a very direct way of solution, and you can just follow these routine, this method, if you are quite confident. Integration of x under root x square plus x. So we'll adopt the same previous methods. X will be represented as the differentiation of x square plus x. So we have a lambda d by dx of x square plus x. Now what is x square plus x differentiation? It will be 2x plus 1, and 2x plus 1 is evidently not equal to x. So you need to have certain constant introduced, which is lambda and mu we have introduced. You can call it as capital A, capital B also, if you are not comfortable with lambda and mu. So 2x lambda plus mu, we have multiplied it inside. So x plus 0 you can assume, because we are equating this similar term. So 2x lambda will be equal to 2x. This 2x lambda will be equal to x, and lambda plus mu will be equal to 0. X you can cancel, lambda will be directly equal to 1 by 2. You can put lambda here as 1 by 2. Mu will be negative 1 by 2. So we have got 1 by 2 and negative 1 by 2. Now replace this, or place it in place of lambda and mu in equation number 1, which just I indicated. So x equals to half 2x plus 1 minus half, which is actually x only. So there is no change. We have just devised a method so that our integration becomes easy. X is only a representation in the form of half 2x plus 1 minus half. So I'm writing essentially half only. So half 2x plus 1 minus 1 by 2. Now multiply this with the following term, which is x square plus x. And there is a dx always there. Now multiply these two separately. That means half I am taking outside. 2x plus 1 will be multiplied with under root x square plus x. So 2x plus 1 into under root x square plus x, you can call it as I1, which is our first term. Second term is negative half multiplied by under root x square plus x, and this is again an integration. Dx I am just not writing. You assume that dx is always there. So I1 is simply, we have a formula, or we have a relationship or result. Fx is x square plus x. Root is actually the power half, so fx to the power half. 2x plus 1 is simply f dash x, which we have got in equation number 1 also. So f dash x is this. I1 is simply fx to the power n plus 1 divided by n plus 1. This is your direct result. What is fx here? X square plus x. Now power is what? Half plus 1. N plus 1. Half is n. Half plus 1 is 3 by 2. And then we have in the denominator n plus 1. Half plus 1. It goes up and it will become formed 2 by 3. 3 by 2 in the denominator will become 2 by 3 in the numerator. And you already have a half here outside. So half, 2 gets cancelled. The final I1 will be equal to 1 by 3 x square plus x raised to the power 3 by 2. This is your I1. Now coming to the second part, which is I2. Negative half you can deal right now, you can deal later also. But the main agenda is to integrate under root x square plus x which is in front of us as I2. I imagine as I2. So under root x square plus x. Now there is no constant term here, but we have a x term here in our quadratic equation. So just divide the coefficient of x, which is 1, divided by 2, square it, add it, subtract it. So I'm adding half square and subtracting half square. So a square plus b square plus 2b, which is x is a, b is half. So a square plus b square plus 2ab formula is already there. So you can write this x square plus half square as x plus half whole square. Now the second term, which is only half square, will remain. So negative half square. Now you can always apply this formula which is presented to you under root x square minus a square. X will be taken as x plus half. A will be taken as half. So let's put this in this formula. You can write x plus half as 2x plus 1 by 2, or you can also keep it as x plus half, because inside log you will always have x plus half, not 2x plus 1 by 2. Now this is x by 2, 2x plus 1 by 2, and then 2 is already there. Under root x square plus x minus a square by 2, a is half square, 1 by 4 it becomes, and divided by 2, which is 2 in the denominator, and then followed by log modulus of, in place of x you can write 2x plus 1 by 2, or you can always write 2x plus half, it's up to you. Then under root x square minus a square, which is simply x square plus x. It doesn't change because after changing only we have got all these, but the original remains the same. Now let's resolve this, and you already know that negative half is also preceding. So we need a multiplication, but I is, what was I1? 1 by 3 x square plus x, 3 by 2. Now I am writing this I2 with multiplication after negative half. So I'm multiplying everything, or the first term and the second term of I2 with negative half, and then writing. So negative is already there. 2 into 2 into 2 will be 8. 2x plus 1 in the numerator. Under root x square plus x. The second term is 1 by 4 into 2. Negative half is already there. So negative becomes plus, and multiplied by half will give you 2 into 4 into 2, which is 4 4s are 16. So we have a 16 in the denominator, 1 by 16. Log remains the same. You can write x plus half, or you can write 2x plus 1 by 2. Please remember, if you write 2x plus 1 by 2, you have to take this log 1 by 2 means as a constant and add with c. So I'm not doing that. Log x plus half I am writing, plus under root x square plus x plus c. So this is your final result. This all is your final result. So this is the result I am talking about, and this is the clear version, because when I explain, I do many things in order to tell you. Now we have x minus 3 under root x square plus 3x minus 18. Now in place of x minus 3, we would like to write something coming out of x square plus 3x minus 18. So x minus 3 will be equal to lambda, any constant you can use, a lambda or mu or a or b, capital A, capital B. So lambda into d by dx of x square plus 3x minus 18. So differentiation of this is actually 2x plus 3. And this is not equal to x minus 3. That means differentiation of x square plus 3x minus 18 is not equal to x minus 3. That is why we have to introduce lambda and mu. And I'm just suggesting that you can always use capital A and capital B in place of lambda or mu, or even you can use your own symbol, not equating or not similar to what is given in the question. Now multiply inside, lambda into 2x plus 3 will be 2x lambda plus 3 lambda plus mu. So x minus 3 equals to this. So now equate the similar term. X will be equal to 2x plus lambda, and 3 lambda plus mu will be equal to negative 3. So x gets cancelled, 2 lambda, and lambda will be equal to half, and 3 by 2 plus lambda equals to negative 3. You already have a value of lambda, which I just wrote as 3 by 2. Now we have the value of lambda and mu. As I was suggesting, you can always have a and b, l and m, any symbol you can use. Now you have to replace this lambda and mu value in the equation, which is the second equation which we wrote. Mu will become, this is going to be 3 to the this negative 9 by 2. So lambda equals to half and mu equals to negative 9 by 2 we got. So you have to place it here and then replace x minus 3 by this equation number 1. So x minus 3, essentially we are writing x minus 3 only. We are not changing it. We are just changing it because we want the integration to be easy. So even if you multiply this half into 2x plus 3 minus 9 by 2, if you do it, you will get x minus 3 on the left hand side. That is the same similar equation only. Just writing in a different way, including this lambda and mu. So half and negative 9 by 2 we have included, and under root x square plus 3x minus 18 remains like that with a dx. Now let's multiply the separate terms. Half into 2x plus 3 will be multiplied by under root x square plus 3x minus 18. So half integration of 2x plus 3 multiplied by under root x square plus 3x plus minus 18. And then multiply negative 9 by 2 by under root x square plus 3x minus 18. So 9 by 2 comes in front, x square plus 3x minus 18 as the second one. Now you already know the I1, which I am calling as the first term, which is simply f dash x we have, which is 2x plus 3. Fx is x square plus 3x minus 18. And when we have fx to the power half, which is under root here, so it will simply give you fx to the power n plus 1 divided by n plus 1. N is half here. So x square plus 3x minus 18 to the power 3 by 2 divided by 3 by 2. And when it goes up 2 by 3, 2 gets cancelled. So I1 we have completed. Let me tell you again that f dash x into fx to the power n, if you integrate this with respect to dx, you will always get fx to the power n plus 1 divided by n plus 1. In our case, x square plus 3x minus 18 is our fx and n is half. So just use this result and you will get the first part of this integration. Now coming to I2, negative 9 by 2, you want to include, you can have it, but you essentially the whole idea is to get under root x square plus 3x minus 18 solved. So I1 is already done. I2 is negative 9 by 2, integration of x square plus 3x minus 18. 9 by 2 we are just going to deal in a bit. Now divide this 3 by 2, that is the coefficient of x. Square it, add it and subtract it. So 3 by 2 whole square minus 3 by 2 whole square. So a square plus b square plus 2ab, x square plus 3 by 2 whole square plus 3x is a plus b whole square. That is x plus 3 by 2 whole square. Now what is remaining? Negative 18 minus 9, 3 is a 9 by 4. You can take just negative outside, negative 9 outside. You'll get 2 plus 1 by 4 here. So 4 to the 8 plus 1, 9 by 4 you will get. 9 is already there, so 9 is 81 by 4. Now the good thing is that 9 into 9 is the numerator and 2 into 2 is the denominator. So you have 9 by 2 whole square. So very nice, you have already got the square 9 by 2 whole square, so that we are ready to apply the formula which you see on the right upper right corner. So x will be equal to x plus 3 by 2 will take a equals to 9 by 2 and apply the formula which is given. So I2 will become negative 9 by 2 integration of this term. So let's write the result and then we'll go about multiplying it with the negative 9 by 2. So x plus 3 by 2 divided by 2, which is essentially x by 2, and then under root this x plus 3 by 2 whole square minus 9 by 2 whole square. If you open it, you will get the original result, which is x square plus 3x minus 18. Then minus a square by 2, which is 9 by 2 whole square by 2, and then we have a log modulus of x is what? X plus 3 by 2, and then plus under root x square minus a square, which is x square plus 3x minus 18. Now let's resolve this. X plus 3 by 2 is what? 2x plus 3 by 2, and you have a 2 in the denominator as well. That means this will become 2x plus 3 by 2, and you have to multiply it by negative 9 by 2, which is in front. So there is no cancellation. So we have 3 2's in the denominator. One from x plus 3 by 2, one already there in the denominator, and then one coming from negative 9 by 2. So you'll get negative 9 by 8 here. And numerator will become 2x plus 3. Under root x square plus 3x minus 18 is like that. Now this is negative 9 by 2 whole square. So this will be 9 square by 2 square multiplied by negative 9 by 2. So 9 9 is 81. 81 into 9 will be 729. And since negative 9 by 2 is multiplied by negative term, it will be plus. So plus 729 divided by what is there in the denominator? 2, 2 square, 2. So it will be 16. Followed by log, and then we have x plus 3 by 2, which is x here, plus and the same term, which is under root x square plus 3x minus 18. It will not change. So this whole from here to here, this first term in the I2, second term in the I2, this has to be added with this I1. So let me write these two together after adding them. So I will be equal to I1 plus I2. I1 was x square plus 3x minus 18 raised 3 by 2, and this will be 1 by 3. Now I am writing I2 here. So just assume that it's not I1 now, it's I actually. I1 already written. Now adding the I2, which is negative 9 by 8 to x plus 3 under root x square plus 3x minus 18, and plus 729 divided by 16 log modulus of x plus 3 by 2 plus under root x square plus 3x minus 18 modulus end, and then combine the constant of integration, write that. So this is the result I was talking about, and you can follow this. There are certain changes you will find in this final result, but the whole idea or the essence of explanation remains the same.